Hello, I'm Michael Mitchell, and I've had the privilege of serving as a high school mathematics teacher at J.P. McCaskey High School in Lancaster, Pennsylvania for over 30 years. Outside of school, I'm a family man at heart. I've been married to my wife, Ala, for 8 years. I have two daughters, Destiny, who's 36, and Jaylyn, who's 24. My daughter Destiny is married to my son-in-law, Dorian, and they've given me the joy of being a grandfather to three awesome grandchildren, Hunter, Harper, and Maverick. They keep me grounded and remind me every day why this work matters. When I'm not teaching, I recharge through cooking, especially smoking just about everything edible, golfing, whenever I can find a good course, cycling, and camping. My friends joke with Allah that they're surprised that I haven't smoked her yet. These hobbies give me a balance, and many of them even serve as a conversation starter and analogies in my classroom. My operational definition of STEM: to me, STEM education is the intentional integration of science, technology, engineering, and mathematics to help students engage with the world through inquiry, design, and applied problem solving. It's not four separate subjects taught side by side, but a transdisciplinary approach that mimics how real-world problems are tackled. As Vasquez, 2013, explains, STEM is not a checklist, but a mindset, one that empowers students to build, test, and reflect across domains. The NGSS Fact Sheet 2016 reinforces this, noting that STEM must be approached through coherent progressions across grades to prepare students for 21st century careers and citizenship. I'm in my classroom. In my classroom, STEM comes to life through the Pool School program. This activity engages students in applying geometry and physics to analyze billiard shots. Students examine concepts like angle of incidence, ball trajectory, and friction, then model their predictions using software simulations. They collect data, calculate optimal paths, and refine their approaches, bridging abstract math with hands-on experimentation. This activity allows students to not only visualize mathematical relationships, but also to communicate findings and debate strategies, mirroring scientific and engineering practices. Referring to Vasquez on page 38, this project embodies multiple integrated practices. From science, students ask questions like, what happens if I strike the cue ball at this angle? From engineering, they define problems such as, what's the best shot to sink the 8 ball under current table conditions? From technology, they use new tools, including apps and simulations, to predict ball movement. From mathematics, they make sense of problems and persevere in solving them using slope, distance formulas, and geometric reasoning. This integration exceeds the sample Mars example from the chart by placing students in the driver's seat of inquiry and iteration, directly applying multiple STEM practices to a familiar real-world system. STEM education, and this is why it matters to me. STEM education is essential because it develops transferable skills like critical thinking, collaboration, and creativity, all while connecting classroom learning to real-life applications. The Framework for K-12 Science Education 2011 highlights how science and engineering practices promote understanding of core ideas and cross-cutting concepts. When students engage in tasks like Pool School, they aren't just learning content, they're learning how to think like scientists and engineers. My goals for this course are threefold. One, to sharpen my understanding of integrated system practices so I can revise and improve my curriculum accordingly. Two, to design NGSS and Penn Stills aligned lessons that are student-driven and inquiry-based. And three, to increase access and engagement in STEM for historically underrepresented student groups, making learning more equitable and culturally responsive. Thank you.